So here we've made a collapsing cloud collapse down. It's spinning fast, and it's in a disk shape. But it's mostly full of gas, some dust, but mostly gas, and so we still need to make planets in it. So here I have my gas cloud collapsing and forming a spinning disk. We've got angular momentum conservation, gives rise to increased rate. As the cloud heats up, you get a lot of the dust will get destroyed. We've got increasing temperatures of gas and dust, and a flattening out because of centrifugal force. And so what we also get is that you'll have regions in which you'll have more material and regions in which you'll have less, and so you'll start to have this disk that has rings of higher density at different distances from the forming sun. So at some density, you've got this gas, it's high density enough, and it's cool enough that you will form small dust grains. So small dust grains are basically like sand or soot. They're micron sized, and they can only exist if the temperature is low enough for that solid to exist. So usually below about 2000 Kelvin. But dust will start to form. This is very much the same way that soot forms as you have gas flowing up from a flame, and as that gas cools, you get the carbon that is in that flame, in that gas, condensing out to give you soot. It's usually hydrogenated because there's lots of hydrogen in there. But once you've got dust grains, they will start to stick together. As they stick together, you'll get pebbles, and then you'll get boulders, and a planetesimal is really something that's kind of boulder size and up. So we're talking about anything from a couple of meters across to tens, hundreds of meters. They will actually collide and stick. Now sometimes they'll collide and not stick. It depends on their relative motions and how much energy they have as they stick together. But we talked about this a little bit as to why you get almost circular motions. And so here you can see you've got lots and lots of things. They've got lots of overlapping orbits. Some of them are elliptical, some of them are circular. And as they hit each other, they will start to clear out and make less and less planets with more and more circular orbits, until eventually you're dominated by a few things, and they will actually sweep up what's left of the planetesimals by collision and by gravity. And so we've got the dust that's clumped and made large particles, forms planetesimals, and you get something that looks kind of like this. And so we have the planetesimals sticking together, and eventually we have protoplanets. So this is another way of looking at this. You have something that's basically made of gas. As it collapses, you get a density enhancement in the center, which has got very hot from collapsing, and is eventually hot enough that it will start fusing hydrogen. Then it becomes a star. But even while it's still a protostar, it will start to form dust. And you can see here you've got gas, but here it's mostly dust that it's showing, and you don't get dust very close to the star because it's too hot. And then eventually you have a small number of planetesimals which eventually collide together and give rise to planets. But you also get that you're sticking these things together, and eventually they have enough size that they will get squished into a circular shape. And this is the way of thinking about this, is that as they collide, they get hot and they may get molten. If gravity can overcome the strength of the rock, they don't even have to be molten. It is the gravity is forcing it into a circular shape. So as gravity pulls in towards the center, this is the most energetically stable shape. And so the biggest things will end up round. They will end up with a spherical shape. Smaller things will not get heated up enough, and gravity is not strong enough, and so they end up still being kind of potato shaped. And so this is how we get a nice circular planet. And then eventually the star switches on and it will clear out any material that's left over, and we'll talk about that next week. But we can also talk about the different types of planets, and that's something that where the chemistry and temperature becomes very, very important. And so now we'll talk about what determines the